All right, so test number 6. You got two identical cars, one with an anti-lock brake system, the other one is without, right? Both of them are going at 30 miles per hour. Okay, so they're going to lock up their brakes at the same time. So the question is, which car, if any, will come to a stop sooner? The one with or without the anti-lock brake system? Okay, so let me tell you about the grading that usually takes place. You get to make 2 statements, at most 3. Okay, the first statement is crucial. If it's wrong, you'll get 0.25. Okay, make sure that you get the first statement correct. You can make an impartial statement regarding the first one, okay, depending upon how long the sentence is. If it's a correct statement, you can get anywhere between half a point to 1 point. All right. So if you come up with one sentence that says which car, 2 identical cars, which one is going to come to a stop sooner, and you're thinking, oh, is it with the car with the anti-lock brake system or without the anti-lock brake system? You can say, oh, the car without the anti-lock brake system is going to come to a stop sooner because it's skidding, which means that there's more friction acting on it. As soon as you say the one with the one without the anti-lock brake system, that's wrong. I don't care what your explanation is, it's wrong. All right, you will get 0.25. Or you can say the car with the anti-lock brake system is going to come to a stop sooner. Okay, you will get 1 point for that one. Or you could say one with the anti-lock brake system. That's not a complete sentence. You will get half a point for that one. The answer is correct, except I'm looking for one single sentence. Okay, so now you have to provide a justification. You can do a partial justification. That's going to give you additional. You can get anywhere between 0.25 to half a point for that. It's going to bring you up to 1.5 points maximally, or you can do a full justification for it, which means that you can get, depending upon the vocabulary that you're using, it could be 1.75 or it could be 2 points. Okay, it depends on how you will justify this. All right, so let me give you a full answer. Which one is going to come to a stop sooner? The one with the anti-lock brake system is going to come to a stop sooner. Okay. Second statement is a justification because it's going to experience static frictional force, or you could say it's going to experience more friction. Okay, that's a full justification there. Okay, I didn't have to explain the details. I'm just making 2 sentence statements. So you shouldn't have more than 3 sentences for this one. All right, number 1, which one comes to a stop sooner? The car with the anti-lock brake system. And now you've got to provide a justification because it experiences more friction. Okay, I didn't have to say static friction or kinetic friction or whatever at this point. Some of you guys have, that's fine. And some of you guys went above and beyond, that's fine. Normally, these things require 2, at most 3 statements. Okay, moving forward, you got a Ford Tempo and an SUV, locking up their brakes at the same time, while moving at the same speed. Both of them are going at 30 miles per hour. All right, so which one will skid to a stop sooner? All right, so the wrong answer is the Ford Tempo will come to a stop sooner, or SUV is going to come to a stop sooner. So if you got 0.25, obviously your answer does not reflect reality. Okay, both of them will skid to a stop at the same time. Okay, that's the correct statement. Now the justification. Because they will both experience the same amount of friction, right? Okay, so that's not the justification in reality. Are they experiencing the same amount of friction? Not really, because sometimes you say the right, so your explanation, your answer is correct, but the justification is incorrect. Are they experiencing the same amount of frictional force? They're not experiencing the same frictional force, guys. So as soon as you start to explain, if the explanation is lacking, obviously you're going to end up losing point. The correct explanation is both vehicles are coming to stop under the influence of a frictional force. There's an opposing force, and the frictional force depends on the weight of the vehicle or the mass of the vehicle. Heavier the vehicle is, the larger the frictional force is. All right, so if the SUV is twice as heavy, frictional force is going to be twice as large. That's it. All right, so I end up providing a lot more explanation than I needed to. So simple 2-sentence explanation is which one will come to a stop it sooner? Neither, both of them will come to a stop at the same time. And the explanation, now the justification is because they're come to a stop under the influence of friction, and frictional force depends on the mass or the weight of the vehicle. Heavier vehicle is going to experience more friction, so it's proportionally more friction. So that's what it means. All right, I think most of you guys got this right. So this was well done. Question number 3: which vehicle, if any, will skid to a stop sign, a motorcycle or a train, if they were initially moving at the same speed? Explain why. Okay, this one is a little bit different. Normally, mass doesn't matter, but in this case, it's not the mass that matters. It's the surfaces will not provide the same friction. Right? The motorcycle is going to be on asphalt, so the rubber on concrete is going to give you a lot more traction than the steel on steel in the case of the train. Okay, so coefficient of friction is not going to be the same. Once again, the short answer is the motorcycle is going to come to a stop sooner because it experiences more friction, because the coefficient of traction, coefficient of friction is larger for rubber on concrete than in the case of the train, steel on steel. Okay, the next question, the anti-lock brake systems. Okay, this is related to the first question. Anti-lock brake system will lock up the brakes 18 times per second. So the question is why? The short answer is because they're designed to increase the average static frictional force. All right, not some of you guys said to maximize the static frictional force. No, guys, you're not maximizing the static frictional force. You're just increasing the average static frictional force. Every time you lock up the brakes, what happens is the static frictional force becomes maximized. The car goes into a skid. At that point, it releases the brakes. So what you're trying to do is you're trying to maximize the average static frictional force, because the average static frictional force in this case is going to be larger than the kinetic frictional force. Okay, so the anti-lock brakes lock up to increase the average static frictional force, and they're trying to make it much bigger than the kinetic frictional force, the sliding friction. I think most of you guys got that right, but some of you guys said it's just the way you pick terminology. Some of you guys said in order to maximize the static frictional force, you cannot maximize the static frictional force. You can only increase the average static frictional force. So the terminology was lacking. Some of you guys end up losing 0.25 to half a point because of it. All right, so we got a cat falling from the top of the Sears Tower. Okay, we know that the cat is going to be more likely to survive the impact with less severe injuries than the cat falling from the second floor. So the question is why? Okay, so for this one, the explanations were kind of all over the place. All right, guys, the cat falling from the top of the Sears Tower is going to reach its terminal velocity. Okay, it takes about 7 floors for a cat to reach its terminal velocity. It's going to be around, from what I understand, it's going to be around about 60 miles per hour or something. And then once the cat reaches its terminal velocity, it's not going to feel like the cat is falling. It's going to feel like the cat is going to feel like it is floating, basically. So the muscles relax. And with those relaxed muscles, the cats are able to increase the impact time and reduce the acceleration. Okay, a cat falling from the second floor is not going to be able to reach its terminal velocity. The cat is going to hit the ground with more tense muscles. Okay, so impact time is going to be much shorter. As a result, the acceleration is going to be much bigger. All right, so that's the only difference. The cat falling from the top of the Sears Tower is going to be moving faster than a cat falling from the second floor, but the cat falling from the top of the Sears Tower is going to be able to, it's going to hit the ground with relaxed muscles, so it's going to be able to increase the impact time and thereby reducing the acceleration a lot more than a cat falling from the second floor. Okay, so